Okay, so my first question is, what makes sense to you from your work that day, and what questions do you still have?
Well, I feel like the whole day was kind of like a review day. We're just still finding the x and the y intercepts. The vertical and the horizontal asymptote. So it was kind of like review. So I kind of understand most of what we did that day.
Okay, so no questions right now?
Not really.
Okay. Will you say in your own words, what is an asymptote?
So an asymptote is kind of like, it's a line with 2 points that go on forever, and they like try to go to a goal. So say there's like a graph here. They try to go to a goal, like say like their goal is to get like here to 0, and they like get closer to it infinitely, and they always get real close to it, but they never actually get to their goal. So it'd be like a gigantic number, like instead of trying to get to 0, it'd be like 0.0000001, and then just keep on going because it will never pass that goal. Okay. However, if it's a horizontal asymptote, it could pass that goal once, but then after that, it does the same thing as a vertical asymptote.
Okay. Will you tell me a little bit about how you find vertical asymptotes?
Yeah, so for the vertical asymptote, you basically have to find the denominator of like a rational function, and you make it equal to 0. So we could take this one for example, x minus 2 equals 0, and then you add 2 to both sides, and then you get x equals 2. So then I wrote it down in here as, the vertical asymptote equals 0. And basically you just do this with every other one. So as you can see here, it's x squared minus 9. You make it equal to 0, you add 9 to the other side, take the square root of both sides, and you get the vertical asymptote equals 3. However, for some things, the vertical asymptote, doesn't always equal like a number, like a real number. Kind of sometimes it equals 0. As you can see here, it's 3x. What times 3 equals 0, and it's just 0.
Great. Why do you think that procedure works? You're saying if you take the denominator and you set it equal to 0, that'll give us the vertical asymptote. Why does that work?
Well, I'm not really sure how that works. I just know that it does.
Okay. And can we pull up the graph on this one?
Yeah, here. Okay, here it is.
Okay. So that's the graph for D, right?
Yeah.
So can you locate where the vertical asymptote is on that one?
So for the vertical asymptote, it's around -1, as you can see here. It goes trying to get to -1, but won't actually get there. And the horizontal asymptote doesn't exist because, as you can see, it's the diagonal one.
Okay. So I think based on your drawing and what you were saying, you're saying that on this graph here, there's a vertical asymptote at -1. So like if we look at this segment of the graph, for instance, if we keep going up and up and up, you're saying that that graph is never going to get to an x value of -1?
No, it'll get like extremely, extremely close, but it'll never actually get there.
Okay. So how can we be sure that if we go forever, that graph is never going to get to -1?
Well, I'm not quite sure, but I feel like a way you could do that, maybe just extend like the window settings for this calculator. Maybe go up to like 1,000,000 or 10 million or however, and then you'll still see it never crosses 1.
Okay.